All right, in this video is just a short review of section 3C that I will be talking about, and it deals with dealing with uncertainty. Now, in this short review, we're going to be dealing with the concept of rounding, and we're going to be rounding numbers to a certain place value position indicated in the problems. All right, the basic process of rounding numbers takes just two steps. Number one, you want to decide which place value, for example, the tens or the ones or the tenths or hundredths, is the smallest that should be kept. And then number two, you're going to look at the number in the next place to the right. Like, for example, if we're rounding to the nearest tenth, you need to look at the digit that is in the hundredths place. That's the digit to the right of the place value position that you're rounding to. If the value in the next place is less than 5, we round down. In other words, that value that we're rounding to remains the same. However, if it's 5 or greater, we round up. In other words, we increase that number that we're rounding to by 1. For example, the number 382.2593 is given to the nearest 10,000. And it can be rounded in the following ways. Like if we want to round that number to the nearest 1,000, then we look at the digit that's in the thousandths place. So in this case here, there's a decimal point after the first 2. So this 2 is in the tenths, then the hundredths and the thousandths. The 9 is in the thousandths place. The number to the right of that is 3. And that 3 is less than 5, so the 9 remains the same, and we drop those numbers behind it. So to the nearest 1,000, 382.2593 will be 382.259. Now let's say I wanted to round to the nearest 100. Well, the digit in the hundredths place is a 5. The digit to the right of that is a 9. 9 is bigger than 5, so that 5 will increase to a 6. So to the nearest 100, it will be 382.26. And then to the nearest 10th, well, the digit in the tenths place, that's the first number after the decimal point, or the first place value after the decimal point, that digit is a 2. To the right of that is 5. That's 5 or greater. That means this 2 will increase to a 3. So it'll be 382.3. And what about to the nearest 1? And sometimes the problem may ask you to round to the nearest whole number. Okay? So the number that's in the ones place is this 2. That's the first 2. To the right of that is another 2. That 2 is less than 5. So this 2 in front remains the same. So 382.2593 to the nearest whole number, or to the nearest 1, will be 382. And then to the nearest 10, we look at the digit in the tens place. That's this 8. To the right of that is 2. Here the 2 is less than 5. So this 8 remains the same, but this 2 will change over to a 0. So to the nearest 10, that would be 380. And then to the nearest 100, the 3 is in the hundredths place. The 8 is the digit to the right of that, and that's bigger than 5. So that 3 will increase to a 4. The 8 and the 2 change to zeros, and we drop the digits after the decimal point. So 382.2593 to the nearest 100 would be, in this case, 400. And some statisticians use a more complex rounding rule if the value in the next column is exactly 5. They would round up if the last digit being kept is odd, and down if it is even. Now, we will not use that rule in this video or in any of the other sections that we talk about in this course. All right, so let's look at some examples. In this case here, starting with example number 1, we're going to round the following numbers to the nearest integer. In other words, we want to round to the nearest whole number. That means we look at the ones place on each one of these. Like in part A, we got 3.21. So in this case here, we look at the number in the ones place. That's going to be the 3. To the right of that is 2. And this 2 is less than 5, so that 3 is going to remain the same. So to the nearest integer, or the nearest whole number, 3.21 will round off to 3. All right, part B, 107.392. Rounding to the nearest integer. Well, in this case here, the 7 is in the ones place. To the right of that is a 3, and 3 is less than 5. So that means that the 7 remains the same. So it'd be 107. Now part C is 10,123.2. 10,123.2. And we're going to round that off to the nearest whole number. So the digit in front of the decimal point is that 3, that's the ones place. And the 2 to the right of that, the number to the right of that, is less than 5. So that means the 3 remains the same. So it'll be approximately, and this is a symbol for approximately equal to 10,123. And part D. Part D is negative 19. Okay, sorry about that. Part D, negative 19.2159. Well, in this case here, the digit in front of the decimal point is a 9. To the right of that is 2. It's less than 5. So we approximate that to negative 19. Okay. Okay. All right, here's another set of problems here. Problem number 2. Here we're going to round the following numbers to the nearest 10th and to the nearest 10. So in part A, we got 548.76. Now we're going to round to the nearest 10th and then to the nearest 10. First of all, the tens place is the first digit after the decimal point. So we look at the first digit after that decimal point, that is a 7. To the right of it is 6. 6 is bigger than 5, so we increase the 7 to an 8. So this will be approximately, now write the answer in red ink, 548.8. That's to the nearest 10th. Now to the nearest 10, we look at the tens place. That's the second digit to the left of the decimal point, and that will be 4. To the right of that is 8. 8 is bigger than 5, so we increase the 4 to a 5. So it'll be 5, 5, and then change the 8 to a 0 and drop the remaining decimal numbers off. So to the nearest 10, it would be 550. Okay, part B, 703.837. Now here we're going to round to the nearest 10th and then to the nearest 10. All right, the digit in the 10th place in this problem in this number is an 8. To the right of that is 3. 3 is less than 5, so this 8 remains the same. So we're going to have 703.8, and the other digits we drop off. So to the nearest 10th, it will be 703.8. And then to the nearest 10, the digit in the tens place is a 0. The digit to the right of that is 3. It's less than 5, so the 0 remains the same. So it's going to be 7, 0. We change the 3 to a 0. So it'll be 700. Okay. All right, part C. We have, in this case, 652.5. Now, the digit in the tens place in this case is a 5. To the right of that, well, there's no digit to the right of that, but that's understood to be a 0 here. And of course, 0 is less than 5, so that 5 remains the same here. So it'll be 652.5. And now to the nearest 10, the digit in the tens place, that's this 5 right here. To the right of it is 2. That 2 is less than 5, so this 5 remains the same. And the 2 changes to a 0. And the 5 behind the decimal point is dropped off completely, so it will be 650. And then part D, we had negative 72.285. Negative 72.285. Okay, to the nearest 10th. This 2 right here, the second 2 is in the 10th place. The digit to the right of that is an 8. 8 is bigger than 5, so we increase this 2 to a 3, so it will be negative 72.3. And then to the nearest 10. Well, the 7 is a digit in the tens place. To the right of that is 2. 2 is less than 5, so this 7 remains the same. So it'll be negative 70 or negative 70. Okay. All right, example 3 looks like this. We're going to round to the nearest 10. Here we got 0.22. Well, we look at the digit in the 10th place. That's going to be the first 2. To the right of that is the other 2. 2 is less than 5. So this first 2 remains the same. So 0.22 would be approximately 0.2. Approximately to the nearest 10th. Okay. All right, number 4 on the next page. Here we're going to round to the nearest 10th again, 8.8065. Well, the digit in the 10th place is the 8. The digit to the right of that is 0. That's definitely less than 5, so this 8 remains the same. So 8.8065 will be approximately 8.8. All right, number 5 is 0.3288 to the nearest 100. Well, let's look at the digit that's in the hundredths place. That's the second digit after the decimal point. That's this 2 right here. To the right of that is 8. This 8 is bigger than 5, so we increase the 2 to a 3. So it'd be 0.3, and then increase the 2 to a 3, and drop the remaining digits. So it'd be 0.33. All right, number 6. Round to the nearest 100, 0.295. All right, to the nearest 100th. The digit in the hundreds place is a 9. To the right of that is 5. Well, 5 is, 5 or greater. That means this 9 we're going to increase it by 1. But here, this is going to be like 29. If we increase it by 1, it will have to be 30. So it'll be 0.30. And yes, we do need the 0 after that 3, because we're rounding to the nearest 100. All right, number 7, to the nearest 1,000 this time, 0.7723. Well, let's look at the digit in the thousands place. So here's our decimal point, tenths, hundredths, thousands. This 2 is in the thousands place. To the right of that is 3. Well, 3 is less than 5, so this 2 remains the same. So to the nearest 1,000, it would be 0.772. All right, number 8. Again, we're going to round to the nearest 1,000. We got 24.7372. The digit in the thousands place, well, here's the decimal point, tens, hundreds, thousands. That's a 7. To the right of that is 2. That's less than 5, so this 7 remains the same. So I'll have 24.737. All right, number 9, we're going to round to the nearest 100. We have 586.1014. The number that's in the 100 place is this 5, because you got the ones, tens, hundreds. Hundreds place, this digit is a 5. To the right of that is 8. Here, 8 is bigger than 5, so we increase that 5 to a 6. These 2 digits will change to zeros. The other numbers after the decimal point drop off. So 586.1014 to the nearest 100 will be 600. And finally, number 10, 499.2864 to the nearest 1, or in some cases to the nearest whole number. The digit in the ones place is going to be the 9. The number to the right of that is 2. 2 is less than 5, so that 9 remains the same. So this will be to the nearest 1, or to the nearest whole number, 499. Okay, so that does conclude this short review on rounding, which is going to be beneficial when we discuss section 3.7, dealing with uncertainty.